All right, hello everybody, welcome back to another video. And in this video, we're going to be taking a look at a question from the IB Chemistry Paper 2 HL from the May 2018 batch, and this is from time zone 2. Now, in this question, they've asked us, hydrogen spectral data give the frequency of 3.28 times 10 to the power of 15 for its convergence limit. Now, calculate the ionization energy in joules for a single atom of hydrogen using sections 1 and 2 of the data booklet. Now, this is a question which should be taught, or how to tackle this question. The concept is taught in topic 2 in case you're wondering. Now I'm going to show you how to do this because I've seen these such questions come up a lot, and I feel like this concept is one of the more underrated concepts, I guess you could say, in the chemistry program because they don't give a lot of emphasis on it. But I'm going to show you here how to do it. It's very, very simple. We only have to use two equations. Literally, for both these questions, we only have to use two equations. One is E, which is energy, is equal to H. Now, H is something called Planck's constant. So I'm going to call it P constant. Now, as you know, Planck's constant can be found in section 2 of the data booklet. They have given it to you there. It's a constant like the gas constant or any other constant that you may know. And energy, or this energy over here, which is basically ionization energy, is equal to Planck's constant times V. Now, what is V? V is frequency. And as you can probably see, how this equation is going to help us tackle the first question. They've asked us to calculate the ionization energy, which is E. And we know what Planck's constant is based on what is given to us in the data booklet. If you go to, if you turn over to section 2, you can see it. Planck's constant is equal to 6.63 times 10 to the power of negative 34. And we multiply Planck's constant by the frequency, which is also given to us in the question, which is 3.28 times 10 to the power of 15. So this is the frequency. We know everything. So this is very easy. Just put this into your calculator and you will find out what ionization energy is. And you should be getting your answer as E is equal to 2.175 times 10 to the power of negative 18. So that is our answer. So that's basically the answer to the first question. That's it. Easy things. You got 1 mark in the bag. So yeah, that's it for the first part. So simple. Just you have to basically just input values in. Nothing too complicated. Now let's look at the next part, which may seem a bit more complicated, but it actually isn't. It also only requires us to use one equation. They've asked us to calculate the wavelength in meters for the electron transition responsible to the frequency in A, which is this part, the previous part, using section 1 of the data booklet. Now, if you flip over to section 1 of the data booklet, just the very second equation, or I'm not sure which version of the data booklet you're using, but if you search for this equation in the data booklet, which is basically C is equal to V times this funky looking symbol over here. I want you to look for this equation. Now, what is this equation? What are all these letters? So C is basically the speed of light. So the speed of light, which is 3 times 10 to the power of 8, is equal to frequency V, which we saw earlier. We saw frequency over here. So frequency, which is 3.28 times 10 to the power of 15, which we know from the question, times this funky symbol over here is wavelength. And this is what we have to find out. We need to find out what wavelength is. As you can see from the question, right? They've asked us to find out what the wavelength in meters is. And since we know already what the speed of light is, and by the way, you can find the speed of light in section 2. It's given right like a few spaces above the Planck's constant. You can find it in the data booklet. Since we know what speed of light is, and we know what frequency is based on the information given to us in the question, all we need to do to find the wavelength is just to rearrange this equation, right? It's basic, it's very simple math. So if you just rearrange this equation, it will look something like this. I'm just going to erase this top part a bit so that I have some more space to work it out. If you want to save, or if you want to take a screenshot of the working that I have done above, please rewind the video and then you'll be able to do so. So we just have to rearrange this equation to make wavelength the subject. So basically we can say that wavelength is equal to the speed of light, which is 3 times 10 to the power of 8, divided by 3.28 times 10 to the power of 15. We've just took this to the other side over here. And this should give you the answer as 9.15 times 10 to the power of -8. So this is our wavelength. And this is the answer to the next part of the question as well. That is it. It's that simple. I'm sure all of you can do this. You're all very smart people. I'm sure you'll be able to do this. Hopefully I have made you understand this topic or this concept well, and how to use these equations and how to approach such questions. I must also mention one more thing. Please do not forget to show your working. I have just put the working below because I don't have space to do the working in these boxes, but you have to show your working. It's an absolute must. You know, it could cost you marks. So please do not forget to show your working. Do show it. And hopefully I've helped you understand this concept a bit better. If you have any other questions regarding this concept or any other concept, please feel free to reach out to me on my social media, my email, or put it down in the comments below. I'll be more than happy to help you. Thank you so much for watching. I'll see you in another video and have a good day.